Hey guys, welcome back to Tronics Energy, and today I'm going to show you how I've made the motion sensor in front of my small DIY house. And remember last time we did a light sensor and it worked very well, and it's still working. If I can just demonstrate to you real quick, I put my hand on top or just anything on top. Once the sensor detects absence of light, it's going to shine a white light inside, and I hope you understood how that circuit really functions. It's just simple, just a simple LDR resistor right there, and some small kind of connections to produce such kind of circuit like that. So for today I'm going to try to explain to you how the motion sensor works and how the circuit component communicate with each other in order to produce such kind of circuit. So if not much saying, let's just start doing the circuit and try to explain how the components are functioning inside. So this is a schematic, and as you can see in the schematic there are a lot of ICs right here. So what I want you to do, just ignore this part, from this part just ignore the rest part of because this was another circuit which I was working on, and the motion sensor it's just the same circuit, only that this time around I was doing another type of circuit using the other ICs right there. So as you can see in the schematic, you can see the LDR right here. Just place the camera right well like that. You can see not the LDR, sorry, the motion sensors. So for the motion sensor we use two. There's a transmitter and there's a receiver. So this is a transmitter. You can see it shooting the infrared rays out, and this one is receiving the rays from this transmitter right here. So this is the receiver. As you can see, the transmitter and the receiver are connected differently in terms of the polarity. You can see the transmitter, the positive is on the positive and the negative is on the negative, but the receiver is actually the vice versa. Negative, positive is connected to ground, and negative is connected to the power supply. So that you should check on that once you are doing these circuits. Right here we have some small resistors. I'm using 1K resistors. They are right here, these two little guys right here, the 1K resistors, these two. And from the receiver, before it gets to the transistor, we take it and feed it to the positive part of the IC. So this IC is just LM358, just a simple comparator IC. There are many comparator ICs out there, but LM358 is such a good one. It's really easy to use, and yeah, so LM358 is the one I'm using. It's a dual comparator. It has two comparators inside. This is the IC, you can see right here. This is the IC, and yeah, so we said that it's a dual comparator. It has two comparators, one on this side, the other one on the top side. So the one on this side, we connected the light circuit with the light dependent resistor, and the one on top is the one we have connected our motion sensor. From the output of the LM358, now there's a quite of a difference. From there we have quite of a different connection, or quite of a different circuit containing this section. So this section, we have NE555, the NE555 timer connected in monostable mode. If you can remember, we did monostable mode some few months back, or last year we did a monostable mode, and I hope you can remember that. For the monostable, we say that once the pin number 2 is triggered, it's going to turn on the output for some specified period of time, which is dependent on this capacitor right here. So the capacitor gives the time at which the output will be on. So once it's triggered, then the capacitor will time how much time it will give a voltage at its output pin number 3. So that's why you can see if I just place my finger it shines the white light for some time, then it turns off. So this time at which it's on is it's determined by the capacitor. So the bigger the capacitor, the bigger the time, or the longer the time you're going to have which the LED will be on. And that's what mostly you see in the motion sensors in buildings and in houses and in gates. Once you pass through them, it shines the light. Then once you're gone, the light comes off. So that's basically what the circuit or the principle on which the motion sensors use. So yeah, that's basically it, and that's basically how the circuit operates. As you can see, it's pretty simple. The port meter right here is the one that is responsible for varying the length. If you want it to be very sensitive, then something that is right here is going to sense the motion. If you want it to be less sensitive, then you can just put it like mine one is less sensitive. My finger has to be a little bit close in order for it to turn on the circuit, as you can see. Yes, so that's basically how the motion sensor works and how the circuit works internally. And as you can see, it's pretty simple. You can try this at home actually, and yeah, the components are really simple. It's not a must that you use the NE555 monostable mode. You can just tap the output from the comparator directly to the LED, and it will just keep on turning it on forever. But if you want something cool like adding an NE555 monostable mode for it to turn off once the person or once the object in front has already passed, then the circuit is right here. And I'm going to put the link for the NE555 connected in monostable mode for those who don't know how to connect the NE555 in the monostable mode. So thank you very much guys for watching. I hope you enjoyed this, and yeah, next time maybe we are going to add something else, maybe a temperature sensor or some sort of that, and maybe it will detect maybe fires inside, and yeah, something like that. So tune in, and hope to see you next time. Goodbye.